Using JSON query parameters, path parameters, or URL-encoded forms feels like magic in Actix Web. These so-called extractors are a fundamental aspect to learn in Actix Web and Rust because they enable you to receive data from a specific request. That's why this video gives you a comprehensive overview of all the important extractors you have to know in Actix Web. So, let's go. Okay, the code you currently see here is from the last video about Actix Web, so feel free to check out this one first. But overall, this implementation is just a simple HTTP server with a pretty cool local memory database. So we are going to refactor this code a little bit and then add specific extractors to our code. But let's just first clarify what even extractors are. So generally, these extractors allow you to extract type data from an incoming request in a type-safe manner. And the definition of extractor is basically in the name. So it basically tries to extract data from things like query parameters, JSON, or path parameters. That really means that it allows you to easily access information in your request handler function without you manually implementing some validation or parsing functionality. So I will cover the most basic extractors, but there are a lot more to cover, like HTTP request. But let's just first start with some modularization of our code. So at the moment everything is one file, and that's not really cool, right? And that's why we are going to extract these functionalities to a models file and a routes file. So for that I've created two different files called, like I said before, routes and models. So let's just first refactor our models to the models file. And obviously model describe really some data structures that we can use to, for instance, describe the data in our HTTP server. So we can say that the user is a model, so let's just extract this one. Now obviously we have to import Serde here with deserialize and serialize. And then we could also say that the create user response we've got here could be a model. So that's not theoretically a model because it just only describes a response. But for the sake of this example, we will include this struct here in our models file as well. Now what we have to do here is to make these models public so that they are available in our main.rs file, for instance. So for that we can just use the pub keyword here. And we also do this for our fields in our struct. And let's just do the same with our create user response struct and with the fields inside of it as well. Now generally the pub keyword just describes that this data is publicly available to other modules. Now I'll create a separate video just about visibility and scoped visibility. But for now pub just means that this struct and the fields inside of it are public. Now let's just go back to our main.rs file, and now we refactor the routes here. So what we got is basically the getUser function and the createUser function. So let's just copy these and then paste them in our routes.is file. Now obviously we have to make these functions public as well. And now both functions are public. Let's use the user.db in our routes.rs file as well. So we have to make this public as well because we use it in our main.rs file. And then obviously we have to somehow use the user here, right? The user struct, which basically is in our models.rs file. And what we could say here to import the user model is just use create models, and then we say user. But because we also use the create user response, we can also import it from the models file as well. And this is how we can import things from other modules. Now to explain this line here a little bit, use just import something. This create keyword basically means that it is our current root path and our current crate we are currently working in. And models is the actual submodule of this crate. And that's basically it, right? Create user response and user exists in our models file. And that's why we can import it here. Now obviously things will not work because we are missing a lot of imports. But let's just first fix our main.rs file by removing some imports. And then obviously we need to import our routes and models module here as well. Now because Rust does not know that routes and models is an actual module, we have to declare this first. Now I'll create a separate video just specific again to these modules and these declarations. But overall this is not pretty to just define the modules inside of your main.rs file. So to define these modules we just use the mod keyword here, and then we use the submodule, which could be, for instance, models. And we do the same for routes. Now what this basically does here is that we now say to the Rust compiler that the models and routes is a module, and the compiler then looks for a models.is file or routes.is file, or it looks for a models directory and then a mod.rs file. So after that, let's just make use of them by importing some modules, like for instance the user. And then we also need to import our routes here. Now in this case they are called getUser and createUser. Oh, and obviously we need to also import our user.db because we use that here as a type. And now the main.rs file is refactored, right? And it should work as expected. Now let's just fix the imports here quickly. And then let's go to our routes.is file, because there we are missing obviously some imports. And there we go, our imports are now fixed and this file is ready to use. Now let's just get into the actual purpose of this video, which are extractors. And the funny thing is that we've already used extractors in our routes file here. So if we just scroll down, we've actually used JSON, which is a valid extractor, which just deserializes the request body to this user struct in this case. Additionally, we've also made use of the data extractor. Now this is another extractor besides the JSON extractor. And generally this data extractor allows to basically access some shared state across our application and across our routes. Now generally it is good to know that Actix Web specifically support up to 12 extractors, and the position of these extractors do not really matter. So for instance, we can just define the db function parameter here as the first argument instead of the second argument. So it's important to note that we can also really customize specific properties of our extractors. Now I'm not going to go too deep into this specific functionality and the advanced functionality and customization of these extractors, but overall it's good to know that you can customize these extractors here. Now let's first discuss the first extractor, which are path parameters, and we've already used them before with our user ID. But generally it allows you to have some dynamic parameter in your route URL. And mostly these path parameters are used to identify a specific resource or multiple resources in your database, for instance. So let's just say, for the sake of simplicity, we just create a public async function, which will just return a friend of a user. So for that, we just create a function here and then we say get user friend. Now in here, we now define this specific path extractor by just using path, and then we can say web and then path. Now to quickly construct the URL we are going to use, let's just use Actix Web and then get, obviously, because it is a get request. And then we say users, then we say user ID, for instance. But after that, we can also say friend ID. So we now have kind of two path parameters. Now the beautiful thing is that this path extractors can basically expect multiple path parameters at the same time. So we don't have to define multiple extractors, for instance, for two path parameters here. So we can just define a tuple and then we can say u32 for the user ID, and we say, let's just say string for the friend's name. So let's just remove the ID here. And then the return value of this function is just a responder, the implementation of a responder. Now we've already discussed the functionality of, for instance, into inner in the last video, so I'm not going to specifically explain this here. But with this function, we can now destructure kind of our user ID and the friend name. So let's just say user ID and then friend. And obviously we can do this because our path extractor has a tuple where the first type is a u32 and the second type is a string. And let's just say after that we just say HTTP response. Then we say OK, and then we say body, and now let's just say format, and we say user, and then we also print out our friend here. And in here we say user ID and friend. And this will work now, right? Now, like I've said before, we can define multiple types in our path extractor, and then obviously we can get them by just saying into inner, and then we can just define another variable here after our friend variable. Okay, this was pretty basic. I'm not going to demonstrate this because this is a pretty simple functionality, right? Now what is really handy is that obviously this path here that we've used as the extractor can become really big if you just use a lot of path parameters in your URL. And we can remove kind of this functionality or extract this functionality to a custom struct. So for instance, we can just say struct and then we say user friend data. And now we just define user ID, which is a U32, and a friend, which is a string. And above that, because we need to deserialize something, we're just going to define the deserialize macro by Surday. And now we can just use this struct in our path extractor. And what is really cool here is that we don't have to use this into inner function anymore, because now we can directly access this data by just saying, for instance, path.user ID, and then we get the user ID back, because we now obviously use Surday and the deserialize functionality directly. Okay, let's just quickly revert everything here, and let's just get quickly into query parameters. Now these query parameters are generally used to kind of modify the HTTP request you're going to send to the server. So this could be, for instance, searching or filtering. Okay, let's just say that we use Actix Web here again, and then it is a get request. And then for now, we just define the user's path. After that, we are going to declare a function, and we are going to call this search by username. And in here, we are going to make use of our DB, because obviously we want to filter or search for something inside of our DB. But then we are also going to define the query extractor here by just saying query and then web query. Now inside this generic argument, we are going to define a struct. Now this is necessary in this case. So we are just going to define a simple struct. Let's just call it search user query, and then we define the name here as a string. And we are obviously going to define the deserialize macro, because in the end we obviously need to deserialize things in our query. And after that, we are going to define this define struct in our query extractor. Now let's just quickly define the return type here as a result. And then we obviously need the implementation of the trait responder, or it could be also an error. Now in here we are obviously going to log the DB again, so I'm going to quickly write this code because we've already explored this functionality in our last video. So we are basically kind of locking the DB here in this case. Now, like in all other extractors as well, we can get the username by using the into inner function. So we're just going to say let username, for instance, and then we're going to say query into inner, and then we use the name here. And this is how we can basically get the name, or in this case the query, from our URL. After that, we need to search for this username in our DB. So let's quickly do this here by just defining the user data. And then we are going to say db.values.find. And then we're going to define a closure. And in here, we're going to say user.name is equal to username. And now we have the possible user data that is matched with the specific username in our query. Now let's just create a simple match pattern here. Now, if there is no user data, so basically if it's not defined, then we are just going to return a simple error not found error here with the message no entries. Now, if there is user data, we're going to say some, and we are going to say user data, and then we are just going to return an OK with an HTTP response of OK. Now the first OK is necessary because we are going to return a result here. And then we are going to say .json. And in here we're going to say user data. And this will now basically return the user data whenever our query matches with some username. Now let's just quickly demonstrate this here in Postman. So we're going to first create a user with the username hello. Now after that, let's just quickly filter or search for this hello name. So we're going to define the specific query parameter here. This is how you can define these query parameters. And then we use name and then hello. Now obviously name is also the same name in our struct. Then we're going to say send, and then we get a 404. Now obviously I forgot something here, because in the end we obviously need to define this route inside of our main.rs file. So let's quickly do that. Sorry for that. So we import here search by username, and then we just say service search by username. Now if you're going to restart the server and just test our functionality again, so let's just create a user and then filter for this user, we now get the name hello back. And obviously this user was found. Now this query is not really good because obviously whenever we change, for instance, here the lowercase h to an uppercase h, it just returns no entries, right? So you can obviously optimize this query, but just for the simplicity, I'm not going to optimize anything. This was just a demonstration. So we can basically now filter by the name here in our local DB. Okay, that was pretty cool. And let's just quickly look at the last important extractor in Actix Web. And the last extractor is going to be URL-Encoded Forms. Now this specific extractor just enables us to get the user data whenever some user basically hits the submit button on a specific form on a web page, for instance. Okay, for that we are going to really quickly refactor the create user functionality here by just defining an insert user function, and then this returns a U32. Now in this insert user function we are basically going to insert the user and most likely copy this functionality here. Now for that we need a DB, and this DB is a mutable reference of this hash map of the user DB here. And then we also need the user data. So we are going to basically mutate our database here by inserting the user data. And after that, we are going to basically define the new ID. So I'm just going to copy this definition of our new ID from our create user endpoint here. And then we obviously can say db.insert. Now, by the way, we do not want the user DB here because this is in the end just an arg and a mutex. We're just going to keep it simple and let the user of this function log the database. So that basically means that we do not want the user DB directly here. We only want the hash map. And then we can make use of the insert function. And in here, we're going to say new ID and user data. And in the end, we are going to return the new ID. And this is now our insert user function. Now we can make use of that in our create user endpoint. Now in here we can just say let new ID, and then we say insert user, for instance. And inside this insert user function we are going to define the function arguments, the mutable reference of DB, but also the user data.into inner. And now we kind of have the same functionality, but we can reuse the insert user function in our URL-Encoded Form endpoint now. So let's quickly do that by defining a new macro here, by defining a new endpoint. And this is obviously a post request because we want to create a new user, and we are going to say users form. Then we're going to define this function. In here we say create user form, and then we're going to say user data web form. Now the form is the Actix Web Extractor here, and this requires the user struct. Now the user struct, just to remind you, just consists of the name field here. So basically now our URL-Encoded Form only has this specific name instead of, for instance, the password as well. Now because we want to insert things into our DB, we also have to make use of the data extractor here, and the return type of this function is the implementation of the responder trait. Now let's quickly just copy the functionality of our create user function. Now here specifically there is no real difference, but I highly recommend to refactor these two functionalities, because obviously here in this case we repeat ourselves and this is not recommended at all. But just for the simplicity, again, we're going to keep it simple, and we are just going to insert the user into our DB by locking it and then creating the user, getting a new ID, and then returning the response here with the new ID and name. So let's just try this out in Postman. So let's go to our post endpoint here, and now we are going to modify the users endpoint to be users form. Now obviously we have to define our route here as well. So let's just do this by saying create user form. And then whenever we try to request something to the user's form, we obviously have to say x www form URL encoded. And the key here now is the name of the user, of the new user we're going to insert. So let's just say name, and then we are going to say hello. So if we send this now, we obviously get a new user back with the 201 created response code. And this now basically works, right? We've defined the user's form endpoint here, and we've defined that it should be a URL encoded form by just modifying this body request. And then we've defined the key value pair we're going to insert into our DB. And this works perfectly fine. And that was basically it. All you have to know about the most important extractors in Actix Web. Now, one of the most known and yet misunderstood keywords in Rust is the move keyword. And I've already made a video specifically for this move keyword in Rust. So feel free to check out this video here as well. Anyway, thank you so much for watching. Have a lovely day and bye bye.